The next generation of AI assistants isn't going to live in the cloud. It's moving to your pocket. But there's a massive technical bottleneck. How do you build persistent, evolving long-term memory on a device with strict storage, power, and privacy constraints? Traditional memory systems assume infinite context windows and centralized databases. They treat interactions as isolated QA pairs. Real mobile experiences are fragmented across apps, multimodal, and deeply personal. You can't just dump raw screenshots, chat logs, and calendar events into a vector store and expect coherent reasoning. The MobileMem framework tackles this with a composite, two-layer memory architecture. First, a system-level blackboard layer maintains global user state, cross-app preferences, and behavioral abstractions. Second, app-specific memory layers handle cognitive offloading. They filter raw interface signals, extract structured events, and only forward meaningful traces to the system layer. This drastically reduces redundant signals and keeps sensitive data local. To evaluate this, the authors built KEME, a knowledge-guided experience synthesis engine. Instead of relying on noisy real-world logs, KEME anchors on structured user personas and temporal constraints. It uses a top-down planner to map course life events, then a bottom-up realizer that incrementally expands sessions, updates persona attributes, and generates temporally consistent multi-hop reasoning trajectories. The resulting benchmarks, MobileMem and MobileMem Omni, test everything from knowledge updates to implicit preference inference and visual reasoning. The results are revealing. Naive RAG and raw long-context windows struggle with distractor-heavy cross-session retrieval. Graph-based and metadata-enriched systems like AMEM and Hippo RAG2 pull ahead by preserving fine-grained evidence, but they're token-heavy. And crucially, captioning images helps visual tasks, but actively degrades text-only reasoning. On-device memory isn't just a scaling problem. It's an architectural one. As foundation models migrate to the edge, lightweight, privacy-preserving memory middleware will be the actual differentiator. If you're building agentic systems, you need to stop treating memory as a simple retrieval layer and start treating it as a continuous learning loop. Check out the MobileMem paper and GitHub for the full architecture and dataset.